Hello and welcome back to the SIRIUS short course tutorial series. In this video, we're going to go over the most important settings to annotate molecular formulas with SIRIUS. For clarity's sake, I'm going to focus on the basic mode settings. Please refer to the text documentation for more detailed explanations on advanced mode settings. The most important setting we have to look at for molecular formula analysis is the choice of molecular formula generation strategy. There are three main paradigms to choose from. Please also again see the text documentation for even more details. First is de novo. Molecular formulas can be computed without limiting them to the space of already known database formulas. This enables the identification of novel molecular formulas not present in any database. De novo molecular formula generation requires restricting the considered chemical alphabet, which can be done via the element filter, which we are going to talk about a bit later. If a novel molecular formula, which in our case means a formula not contained in one of our structure databases, is assigned to a feature, this feature obviously cannot be annotated with a database structure, since no structure exists for that formula. But SIRIUS can still predict a molecular fingerprint, assign compound classes, and generate structure leads using MS Novelist. If we are only interested in full structure elucidation using CSV Finger ID structure database search, we can just choose another paradigm. And that would be database search. We can restrict the space of considered molecular formulas to those formulas that are present in our structure databases that we are going to search in for structures later. By doing that, we guarantee that every molecular formula we annotate also has a potential structure candidate. Since the space of molecular formulas is now already very limited, we do not need to restrict the chemical alphabet, and computation times on average will be much faster than using pure de novo. However, for every feature which true molecular formula is not contained in one of our databases, we will not be able to annotate it with the correct formula. A combination of both approaches is the bottom-up approach, which generates novel molecular formulas by combining database subformulas. This approach covers a larger space of molecular formulas than pure database search and can produce some novel formulas as well. However, since not all theoretically possible formulas can be explained as subformulas of what is present in our databases, this approach does not cover the complete theoretical space of de novo formulas as the pure de novo approach would do. It is, however, much faster than de novo and does also not require predefined chemical alphabet restrictions, which is very nice. And then the last option that we have is, if we want to test a predefined custom set of molecular formulas against our data, we can do that by providing the formulas in question directly. Please note that this is not recommended as a default, as we can rarely be sure that the couple formulas that we input in here are the complete set of formulas that we might be interested in. Since de novo annotation is only slow for higher mass features, we recommend using the default combination of bottom-up search and de novo for most analyses. This will perform de novo analysis as well as bottom-up search for masses below the threshold, which per default is 400 Dalton, and then bottom-up search only for masses above this threshold. Lastly, we are going to take a look at element filtering. As mentioned, for some methods, specifically de novo, it might be necessary or beneficial to limit the allowed quantities an element can have in our molecular formulas. The element filter consists of two parts, the allowed elements overview and the auto-detected elements overview. SIRIUS is able to detect the quantities in which certain elements can occur from the MS1 isotope pattern. This is not possible for all elements, and we can see the list of elements that we can currently auto-detect here in this auto-detect window. By clicking on this small button here, we can en or disable the auto-detect feature on a per element basis, like this for example. We can also change the allowed quantities for other elements. For example, we can say our formulas need to contain between 1 and 3 fluorine, like this. And if we then apply the filter, we can see our updated list of allowed elements up here, and then we can also see our updated auto-detected elements at the bottom. Enabling the element filter for bottom-up and database strategies is optional. It can just be used to pre-filter formulas based on prior knowledge that you have that a certain element should not occur for this specific feature or occur in a certain quantity.